In this chapter, we're going to look at some additional ways to write the ionic solutions in terms of a reaction, as well as some of the simple calculations that we can do beyond what we've learned about so far. The first thing, in section 1 of chapter 13, three things we're going to look at. Writing the reaction, the dissociation reaction for when a chemical dissolves in water. Number 2, look at the solubility rules of a reaction. What we mean by that is being able to predict not only what the products are, but what state they are, solid, liquid, aqueous. And then the last thing, write the net ionic equations. And the net ionic equations are basically a simplified reaction showing only what changes. Now, to be able to do this, you've got to be able to go back and review some things in chapters 7 and 8. You got to remember how to write formulas and chemical names, things like that, ions, their charges, and then be able to write reactions, okay, and predict products. So you may need to go back and do some review on that, because what we do next, we're going to add to it. The chapter, I would say about 75% of the chapter is kind of review with that information. So first thing, dissociation reactions. If we're looking at a dissociation reaction, what we're basically talking about is writing a reaction that shows how a chemical dissolves. So I've got 3 different examples here. Now in all 3 examples, I've actually writing plus water. But I put in parentheses because really we can ignore it. We do not actually have to write it if we write the reaction correctly. So if we take solid sodium chloride and dissolve it in water, what happens is the ions in that ionic compound, sodium chloride, those ions separate into their individual structure, and they are now dissolved in water. That's why we have the term AQ. So really, if we look at all 3 of these, when an ionic compound dissolves, it breaks apart into its 2 ions. The simplified way to write the reaction for when something dissolves, or its dissociation reaction, is simply the solid chemical changing into its 2 ions that are now dissolved in water. Therefore, we write AQ. So that's all we have to do. We see the phrase dissociation reaction, that's what we write. There's nothing more to it. It's that simple. It's kind of like going the opposite direction of figuring out a chemical compound's formula. We have the 2 ions. Sodium's a +1 charge, chlorine's -1 charge. +1, -1 go together, cancel out. Boom, we have our compound. Okay. Second thing we're going to talk about in this chapter is what's called solubility reactions. What we're trying to do is predict whether or not a reaction will make a solid. So review, back from chapter 8. We take sodium chloride dissolved in water, and we take silver nitrate dissolved in water. We know back from chapter 8, metals trade places. So we can see here the silver and the sodium trade places. We make sodium nitrate, and we make silver chloride. Back in chapter 8, though, we kind of said, hey, we don't know what's a solid or a liquid or aqueous or any of that stuff. So I would have said, just copy it down. We'll figure out later what it actually will be. Well, now is later. So what you want to do is look at on page 437 in your book, and there's other solubility charts out there that you can find. And we want to be able to look at that chart and determine whether or not a reaction actually does have a solid precipitate. So if you look on that chart and you read down through those statements, you're trying to find a statement that tells you something about this sodium nitrate compound or something about this silver chloride compound. And if we read those rules, statement number 1 and number 2 both tell us something about sodium nitrate. Statement number 1, most sodium, potassium, and ammonium compounds are soluble in water. Great. Number 2, most nitrate, acetates, and chlorates are soluble in water. Good. So both of these are statements that tell us that's not going to be a solid. Does there have to be 2 statements? No. But if there are 2 statements, they cannot contradict. All right, so let's look for silver chloride. There is no single statement about silver specifically, but it does tell a statement about number 3, which says most chlorides are soluble except silver. So in statement 3, it tells us that this chemical right here will end up forming a solid. So if we were to do this reaction, sodium chloride plus silver nitrate, 2 chemicals dissolved in water, we're going to still have a chemical dissolved in water, and then we're going to have a solid precipitate, sodium or silver chloride. So, you're going to be able to use the chart, and that's it. You do not have to memorize it. So, if we look at these three, what I want you to do is two parts. Number one, I want you to find the products, and then number two, identify, is there a solid? And the way I can answer this or give you some more information is there is one solid in each reaction. So when you look at the chart, you may not, let me put it this way, you may not find the solid, but you might be able to eliminate chemicals from that. So I'm going to pause this. I want you to write the products and then determine which one of the two products forms the solid. And after a few minutes, then you can go back and we'll talk about them. Okay, so if you look at the solubility chart, you can go down through the different statements and you can find that in rules 1 and 3 clearly tells us that salt will be an aqueous solution. We can go down to rule 4, which is an exception for strontium. So strontium sulfate would be a solid. Second example, again, we find sodium and sulfate. Rules 1 and 4 clearly state that sodium sulfate is aqueous. Now, it does not specifically say copper hydroxide, but again, if you remember what I said at the beginning, every reaction has one solid. So if the sodium sulfate is not a solid, the copper hydroxide must be. That'll be important. Read the question. If the question doesn't tell you solid, then you got no clue. Potassium nitrate, again, were rules 1 and 2. Clearly states that it's aqueous. Therefore, we don't know anything about lead. And again, if the question states there is one solid, then we know lead iodine is the solid. The little tweak here that we can do, iodine could be treated like chlorine. And then we've got rule number 3 that states lead chloride is not soluble, therefore lead iodide is not soluble. Right? So this is probably the most important thing of the chapter, being able to predict this solubility. And yes, you will be given the chart. You do not have to memorize the chart. Next thing, we want to write the overall ionic reactions. So all we're going to do is we're going to take a formula equation, just like this, and everything that's aqueous we need to break apart into its ions, just like we're going a dissociation reaction. So sodium chloride dissociates into sodium ions and chlorine ions. Silver nitrate dissociates into silver ions and nitrate ions. Sodium nitrate dissociates into sodium ions and nitrate ions. And then we have solid silver chloride. That right there is an overall ionic equation. Now, this one, it's a lot to write, so we don't like to write this very much. Like I said, it includes the most writing, but it will use it the least. A lot of the times we can sort of do this in our head. So again, all our purpose is anything that's aqueous, it breaks apart into its ions. If it's a solid, we keep it together. That's the definition of an overall ionic equation. The reason for this is going to lead us into the next type of reaction. So we're going to look at overall, and then we're also going to look at net ionic. So if we come back to our net ionic, or our overall ionic, we would have 2 sodiums and a sulfate. We would have strontium ions plus 2 chloride ions. And again, if we go back to what we learned here, here's our 2 products, salt and sodium sulfate. Salt was aqueous, and then strontium sulfate was a solid. So there's our overall ionic. Now, our net ionic, we're only going to show what changes. Okay? So here's what I'm going to have you do. We went through, and I want you to write the overall ionic equation for these other two, and then I'll come back and we'll look at the net ionic for these three. So I'll pause this, come back, and give you a chance to look at these. Okay, so if we look at these three reactions, we now have the overall ionic in all three cases. Now what the net ionic is, we only care about the things that changed. If we notice here, we have sodium ions and chlorine ions. We still have sodium and chlorine ions. We have sulfate ions and sodium ions. We still have sodium and sulfate ions. We have nitrate ions and iodine ions. We still have, I'm sorry, not iodine. I messed that one up. Let's try that again. Nitrate ions and potassium ions. And we still have potassium and nitrate. So those have not changed. That's a net zero. What has changed are the other components. If we notice here, sulfate and strontium started out as ions. Now they're not. Copper and hydroxide started out as ions. Now they're not. And finally, lead started out as ions, and so did iodine. Now it's lead iodide. So if they say write the net ionic change, it would be sulfate ions were aqueous, strontium ions were aqueous, and now we have solid strontium sulfate. Copper ions were aqueous. Hydroxide ions were aqueous. Again, we got a balance still. And now we have solid copper hydroxide. And then finally, lead ions were aqueous. Iodine ions were aqueous. And we were left with solid lead iodide. So we've got formula equations, overall ionic, net ionic. The formula and the net are the two most important. Again, just one more big example here. Calcium sulfate plus lead nitrate makes calcium nitrate and lead sulfate. I do need to bounce here, so a 2 and a 2. Okay. So there's the formula equation number 1. Here's the overall ionic number 2. And then the net ionic is only showing what changes. And again, what changed here in this second reaction is we have sulfate and lead ions that formed solid lead sulfate. So there's our net ionic equation. Okay. Last thing I'll leave you with here, just a couple reminders. So a little checklist here. For ionic equations that are not formula equations, we got to show all the ions. We got to use the chart and know the difference between overall and net. Overall, we show it all. Net, we only show the changes. So again, we've done this a couple times here. Those are the three types of reactions that we will have to deal with the first one and the third one being the most important. All right, so I'll just leave you with this reaction here, potassium sulfate plus barium nitrate. Write 3 reactions. Number 1, write the correct formula equation. Number 2, write the correct overall ionic equation. And number 3, write the net ionic equation. And at some point, this can be a show me in class. Okay, so that's one small piece in section 1 we'll take care of on the next video.